Okay, so now that we've collected all of our data, we can now start to analyze it. And in order to do this, we will be conducting a two-proportion z-test. So before we conduct our test, we have to run through a number of assumptions. For instance, we have to assume that this is an independent, simple random sample. Independent, simple random sample. This is completely false. There is in fact no way that this could happen. It's a complete convenience sample because we couldn't abduct people and say, hey, I chose you randomly. Please give me your opinion whether or not you find these two gentlemen dateable or not. That's just not going to happen. So we have to just ignore this and say that we proceed with caution. That'll fix everything. So we don't even need to worry about that now. Proceed with caution. Now that we have that out of the way for the most part, we can go to the other assumption. Outliers. This is a proportion test, so there's no outliers. And then normality. Okay, so we have a sample of size 50, and we have to test that NP and NQ are both bigger than 5. So since our sample is of size 50, P or Q, this is combined, have to be bigger than 5. So 50 times that has to be bigger than 5, or P combined has to be greater than 10, or 1/10, excuse me. And then Q combined also has to be greater than 1/10, since it's going to be the exact same thing. So as long as they're bigger than 10, and we'll just check our results from our printout. And here's the test for subject B. P combined is 0.63, which is bigger than 1/10. And then Q will also be bigger than 1/10, so we're good there. And then 0.68 times 50, all that P combined will be bigger than 0.1, and so will Q combined, so we're good there. Now that we have all these assumptions, we can start to proceed with the data analysis. Okay, now that it's cleared, we can proceed. So two proportion z-test. We'll be doing this by let me change colors real quick. In a nutshell, we'll be doing whatever our p value is, our p hat, excuse me, 1 minus p hat 2 over the standard deviation of the sample, so that, and that'll give us a z-score. And then with that z-score, we can figure out where this is going to lie. And okay, now that we have that established, we have to set our hypotheses. So our null hypothesis is that, and this will just be general for both sets of data. Our hypothesis, let me make this a little bit bigger, will be that the proportion of people who find the subject dateable, and this will be for either subject, so I'll just put an X there. You can substitute K or B in for X. This is just for the general form. So the proportion of people who find the subject dateable in casual attire minus the proportion who find him attractive in formal attire is equal to 0. And then the alternative will be that the proportion of people who find the subject attractive in casual clothing minus that proportion in formal attire will be less than 0. or in essence, we'll be saying that he'll be more dateable in formal attire, in essence, because you can just do some algebra, move that over there, and you're good. Okay, so we have our hypotheses set. We have our formula in general set. So, oh yeah, S of x is going to be equal to the square root of P hat combine, excuse me, Q hat combine, over, actually no, we could do it like this. So, and 1, which is the sample size of the first sample, inverted, plus n2, which is the sample size of the second sample, inverted, all square rooted. Just square root of all that. And that'll be the standard deviation of the sample, which will be going right here. So, I've already conducted these tests, and I have the printout available right here. So for subject K, which is Kenan Kiever, in case you didn't realize, his z-score will be equal to negative 1.29, and his p-value was equal to 0.099, and this is for subject K. And for subject B, let me just get this set up. For subject B, his results were z-score of negative 1.45, negative 1.45, and a p-value of 0.073 or 0.074. So now that we have this data, what can we say? Well, at a significance level of 5%, these two p-values won't exactly cut it. But that's okay, we can change that. We can just say that alpha will be 10%, and we'll be all set. And hey, look, now it's significant. So now that we know that, we can go ahead and say that we have evidence now to suggest that the null hypothesis is false. So we reject the null and we accept the alternative.